Most of the information on iron beam seems to be classified. This is my meager understanding of the system, based solely on the internet. Iron beam uses a multitude of fiber lasers, providing coin-sized coherent beams at the target. The available literature indicates this reduces beam dispersion and bloom effects. The specific laser frequency is not listed. I assume it is somewhere in the infrared band because longer wavelengths tend to be less attenuated by the atmosphere. This is the reason the sky is blue and sunsets are red and orange. According to the literature, when one of the small beams detects a target, the system then focuses all of the hundreds of beams onto a small coin-sized spot on the target to heat the spot to the point that the target is damaged and fails. The power output of iron beam is 100 kilowatts. Using an assumed wavelength of 1000 nanometers, a beam area of 2 square centimeters, a target spot of 2 square centimeters, and a target skin thickness of 2 millimeters, I calculated the energy delivered to the target spot in joules versus distance. The iron beam total aperture is a diameter of 450 millimeters. This allows a maximum of 795 laser fibers of 2 square centimeters each. I assumed the target skin is aluminum. Other than atmospheric attenuation, the main problem for laser weapons is dwell time on the target to produce enough heat to melt and damage the target. It is generally a few seconds. This requires very sophisticated tracking systems in conjunction with the beam hardware to keep the beam on the target spot. I assumed a dwell time of 5 seconds. This figure shows the delivered energy versus the energy required to melt the target spot, Q melt. Note that 2 different atmospheric attenuations are shown, clear air and haze. For clear air, the maximum range to Q melt is approximately 10 kilometers. For haze, it is reduced to approximately 600 meters. Heavy haze and fog reduce it to essentially non-useful ranges. There are multiple articles dealing with atmospheric attenuation of laser beams. There is little consistency. I used a source that provided attenuation in dB per kilometer in the infrared band. More experimental work needs to be done. However, iron beam is clearly working at useful ranges as shown by various videos on the internet.